All right, so this is day 2 of our 8.7 lesson. And today I want to show you how to do the same thing you were doing by hand using your TI Inspire calculator. It's very easy, but it takes a little bit of practice in how to insert your data and then how to analyze it. So I want to show you how to do that today, and then you can use that on your practice for tonight. So we're on the Statistical Measures Day 2 sheet. I apologize, it says Objective 8.7 Guided Practice. It should say Guided Notes. And there's a little picture of a guy on a bicycle. That's the page we're working through today. So it starts out by saying that we're going to look at the effect of an outlier. And it gives you the definition that an outlier is a value that is much greater than or much less than most of the other values in the data set. So in order to see what effect an outlier has, we're going to start with a set of data where our values are within the same general vicinity of each other. And then we're going to look to see what happens when we add something that's significantly different. Okay, so if you don't have your TI Inspire calculator with you, stop the video right now. Get it out and get it to this home page so that you can follow along and assess the data that we're going to be working with. Okay, so I trust you have your calculators ready to go now. So from this home page, we want to open a new document. The calculate and the graph over here are just for quick things. If you're really working with things, you really want to be working with documents over here. So we're not interested in calculate or graph over here. We're interested in a new document. So we're going to push 1, or you can click on that with your cursor. Okay, and then you get this list of all the different kinds of screens that you can get in the TI Inspire. Well, our first task is to enter the data that we see there for the number of miles that this person has ridden their bike for 7 weeks. So we need the list and spreadsheet screen so that we can input this data into the calculator so that we can use it. Okay, so number 4, lists and spreadsheets. And what you're going to get is going to look like a spreadsheet. Okay, you've got the cells here, you've got your columns, your rows. Columns are labeled with letters, rows are labeled with numbers. But we're going to be even more thorough, and we're going to name our column miles. Okay, so using your keyboard down here, we're going to type in miles and then hit enter, and then use your arrow, your down arrow, to go down one more cell. If you hit enter when you're in this cell, you're going to get something that looks like this, and it's waiting for you to put in some sort of equation. We don't have an equation. We're just entering data. So if you accidentally do that, just hit your escape button up here, and it'll get rid of that. And use your arrow to go down to our first cell here. Okay, and so now we're just going to enter the data as they give it to us. So the first week you went 17 miles, then you went 20 miles, 16 miles, 18 miles, 22 miles, 19 miles, and 20 miles. Go ahead and pause the video for a moment if you need a second to get that data entered. All right, now, what A is asking us to do is find the mean, median, mode, range, and standard deviation of this data set. So all of the same measures we were talking about in the first day, but now we're going to do it with the calculator. So keeping this cell highlighted, keeping a cell in this first column highlighted, we are going to go to the menu. And when we click on the menu button, we get this menu of choices. And you can see here that number 4 is statistics. When you put your cursor over statistics, or when you type 4, since it's number 4, you get another menu that says stat calculations. So these are statistical calculations, which is what we want. All those different measures are different calculations. So if you put your cursor over that, or again, just type the 1, then you get another menu that gives you all the different kinds of calculations you can do. We are interested in one variable statistics. Okay, so let me show you that again. Menu, statistics, stat calculations, one variable statistics. Okay. Again, pause the video for a second if you need to write those things down, because you will be expected to know how to do these on your calculator. All right, so if we click on one variable statistics, we're going to get a few dialog boxes here that are going to ask us how we want to set this up. So the first question is number of lists. Since we just have one variable of data, which is miles, and we've put it all in one column here, we're just going to have one list. So we hit OK. And then it's going to ask us, where is your data? What list is it in? So since our data is in the A column, we're going to get A here. And the reason A is coming up here is because I left my cursor in the A column. Okay, that's why you want to leave it here, so that A is going to come up here automatically and you don't have to change anything. If you do need to change something, see how my cursor is blinking at the end? I would want to back up using my back arrow, and then I would want to delete this and type whatever letter I needed in there, but I need to leave these two brackets as part of that label. Okay, it's part of the syntax, doesn't understand if you don't have those in there. Okay, the frequency list can stay as 1, and then my results, what they print out, is going to start in column B. Okay, that's an available column. I don't have anything typed in there, so they're going to start in column B. And so you hit OK, and there's a lot of information. Okay, so here's our column where we entered our data. Now we have two columns for results. The B column is telling us what kind of result they're giving us, and the C column is telling us the actual result. So as we saw in our previous day's lesson, the X with the bar above it is the notation for mean. So 18.9 approximately is going to be our mean. Okay, now there's some measures in here that you don't really need to know. This is sigma. It's a Greek letter. It means summation. So if you add all of the X values up, you get 132. Okay, not that you need to know that, but that's what it means. This means we're adding up all the squares of the numbers. That gives us a 2,514. Again, not something you need to know. There are two types of standard deviation here. Okay, the SX and the lowercase sigma x. This one, the sigma x, is the one we talked about last class, and it's the one that we're interested in. This is what's called a sample standard deviation. This one is called a population standard deviation. It's a little more complicated, and it's not something we're interested in right now. So we're interested in the sigma x, and that's at about a 1.88. So standard deviation for this data, 1.88. So that's a pretty small number. That indicates that our numbers are pretty close together. Okay, N represents how many data values we had. So we had 7 data values. Then we have min x, q1x, median x, q3x, max x. Okay, so min x gives us our minimum value, which was 16. Max x gives us our maximum value, which is 22. In the middle of that is our median x. So our median for this data was a 19. Okay? Now, these Q1x and Q3x stand for quartiles, and we're going to see what quartiles mean and how they're useful in our next lesson. So just know that they're there for right now, but we're not going to use them for right now. However, we are going to use the max and the min because there is nothing here that tells us actual range. So we need to simply use the max value and the min value to subtract and get a 6. So out of the 5 measures you're asked to find, the only one that this analysis does not give us or does not help us with is the mode. The mode you have to look at your values and figure out for yourself. And if you look back at our list of values, which value shows up more frequently? Well, hopefully you see that's the 20 because everything else only happens once, but the 20 happens twice. Okay, so now you have all 5 of your measurements. You've got the mean from up here at the top. You've got the median from right here. Mode, you have to look for yourself. That's the 20. The range you can get from taking the max minus the min. It'll sort that out for you. So no matter what order you put things in, it'll figure that out. And then the standard deviation is right there. Okay? So if you need to, pause the video, go back, re-look at how we got those values, make sure that you're comfortable with how that works before we go on to part B. All right, so moving on then. So now in part B, they're saying your mileage the next week is only 3 because you were sick most of the week. Find the new mean, median, mode, range, and standard deviation with 3 included in the data set. Now, if you were doing this by hand, that would be quite tedious because you would have to refigure everything with that 3 involved. Okay, but what's nice with the calculator is because this data is based on whatever's in this column, if I just come here to the 8th cell and add 3, watch what happens when I hit enter. All of these numbers change because now 3 is part of the data. So I don't need to recalculate everything by hand. The calculator recalculates everything for me. So now if we come up and look at our measurements, now my mean is a 16.9 rounded off. Now my standard deviation is a 5.53. So you can see what an effect that much lower number had because now things are much more spread out. So my standard deviation got larger. I now have 8 values that have a minimum value of 3 and a maximum value of 22. So now my range is going to be 19, 22 minus 3. My median is at 18.5. So remember in part A it was a 19, now it's an 18.5. That one didn't change very much. And then the mode is still going to be 20 because that is the one that still happens the most. But you can see now which measures the 3 really affected. Okay, 3 is much less than all the other numbers that we had. So 3 is what we consider an outlier. Okay, it's not really in the group with all of the other numbers. And so when you look at these different measures, which one seems to have changed the most? And especially when we talk about measures of center in part C, the measures of central tendency, which one did the outlier affect the most? Was it the mean? Was it the median? or was it the mode? Well, I think you can see pretty clearly the mean is the one that changed the most. This was a number around 18.8 or 9 in our first set of data. Now it's down to a 16.9, whereas my median only changed from 19 to 18.5, and my mode didn't change at all. It's still 20. So even though we feel sometimes that mean is the more real measure of center, it's not the most real sometimes. It is the most familiar. And so when we talk about a number that represents the center of the data or the most typical data, it's easy for us to think we should always choose mean because it's more real. Well, it's not. It's more familiar. But there are times where mean actually does not give us a good representation. When you have an outlier like this 3, the mean takes that into account, and so that big spread gets added in and then divided, and so that can skew that middle number. But if we take a look at the median, adding in this 3 just meant there was one more value in the list to have to choose from. And so when we start counting from the ends, 3 is just one more spot that we have to count through. It doesn't really affect the number that much. So an 18.5 is probably a little bit more representative of this data because of that 3 being in it than the mean was at 16.9. Okay. And then the mode, I mean, if that's the one that you've ridden the most often, sometimes that can be even more representative of what the typical value might be. So you have to keep this in mind when you're talking about data. If you have outliers that are quite a bit less or quite a bit more than the rest of the data, you have to understand that the mean is going to be the most affected by that and may not be your most representative number. The median, on the other hand, is less affected by that and is sometimes a better representation. And then for part D, where it asks what effect does the outlier have on range and standard deviation, well, obviously both got bigger. Our range went from 6 to 19. So obviously the data is much more spread out now because we're going down to 3 rather than going down to 16. So our range got quite a bit bigger. And so did our standard deviation. Remember, this standard deviation was a 1 point something the first time. Now it's at a 5.5. That's a pretty significant increase just because of that 3 being in there that spreads the data out much more. Okay, so a couple of things that you need to take away from this lesson. One is the ability to use the calculator to get these measures of center and of spread, of dispersion, so that you don't have to do it by hand all the time, especially with standard deviation. It's much, much easier to do that on the calculator in this manner than to try to hand calculate it every time. And 2, understand the effect of an outlier, what it is and what it's going to affect more, and which measures are actually more representative when an outlier is present. All right, that should be what you need to do the practice. So the objective, excuse me, the objective 8.7 practice for day 2 is right after the day 1 practice. Sorry, those got a little bit mixed up. We ended up with the 2 notes side by side and then the 2 practices side by side. Okay, so if you just flip a page, you should see the day 2 objective 8.7 practice. You should be using your Inspire to work these out. I do not want you working these by hand. Work them out using the Inspire. Practice setting this up on your calculator. All right, that's it for today. We'll see you next lesson.